Good day, everyone. So, for the focus of our discussion for today, we will be discussing the measures of central tendency and dispersion. So, these two types of measurement are actually classified under the descriptive statistics, as we have tackled during our introduction for this course. This is very important that we compute for the measures of central tendency and dispersion before we proceed with the inferential statistics, which would be the main focus of our lectures this coming midterms. So let us now proceed with our lecture for today. The first one that we have would be the measures of central tendency, which is actually referred to sometimes also as the measures of central location. So, as the name implies, these measures of central tendency would refer to a single value that would attempt to describe the central location of a data set. So for our measures of central tendency, you need to just remember our three M's. We have our mean, our median, and lastly, we have our mode. So let's discuss each of the different measurements one by one, starting with our mean. So for our mean, this is also known as the average. So this, out of all the three measures of central tendency, is considered to be the most popular or well-known measure of central tendency. It can be used for both discrete as well as continuous type of data. So it is simply computed as the sum of all of your data divided by the total number of data from your data set. So let's write it down. Your mean can be expressed in two symbols. It may be an X with a bar on top, which is the most common symbol that we utilize to refer to the mean, or you could also utilize the mu symbol. So the mean is again simply the sum of all your data divided by the n, which is again the total number of data. So let us simplify the formula. It could be x with a bar on top is computed as the summation of x over n, or mu is computed as the summation of x over n. So x would be referring to your data, and your n would be referring to the total number of your data. So let us have an example. So let's say that I have recorded 5 quizzes from a single student enrolled in biostatistics and epidemiology. So this first row is the quiz number, and the second row would be for the scores. So I have, again, a total of 5 quizzes from a single student. Her scores would be 18, 12, 15, 17, and the last quiz, she got 16. So for the computation of our mean, it would simply the sum of all of our data, 18 plus 12 plus 15 plus 17 plus 16 divided by the total number of data. So for your scores, we have a total of 5 quizzes here. So let us compute for our mean. 18 plus 12 plus 15 plus 17 plus 16 is equivalent to 78 divided by 5. And our mean for this data set is 15.6. But do take note that there is actually a downside with our mean or our average. The major disadvantage of the mean is that it is particularly susceptible to the influence of what we call as outliers. These outliers would simply refer to those values that would either be too high or too low as compared to the other data from your data set, and it is actually considered to be too far, or the distance between your mean and a certain data that we consider as our outlier is too far from one another. So let us have another example. So let's say we still have a total of 5 quizzes, and the scores would be as follows: 18, 12, 15, 17, and for the last quiz, the student got 1 only. So visually, we could observe that these score for the last quiz of this certain student is too far compared to the other scores that she obtained from the previous 4 quizzes. Let us now compute for the mean for this given data set. It would be now 18 plus 12 plus 15 plus 17 plus 1 divided by 5, which would still be a total of 5 measurements or scores for the given quizzes. And it will now be computed as 18 plus 12 plus 15 plus 17 plus 1. So that would be equivalent to 63 divided by 5. And it will now give us a mean of 12.6. So there is actually a deviation or actually a spread of our data wherein you have one specific data that is far from the other measurements that we have, and comparing also with the computed mean that we have here, your outlier is also far away from the computed average or mean. If you will be comparing it from the first data set that we have, most of the scores that we have here are near each other. And comparing them also with the computed mean, there is not much of a difference of your scores with the computed average or mean from the first dataset example that we have. Next type of center or measurement of central tendency that we will be discussing would be the median. So your median would simply refer to the middle score from your dataset. But do take note that we need to arrange the data that we have before we could obtain the median. Unlike with the computation of the mean, regardless of the arrangement, you simply add all of your data and divide it to the total number of data that you have. But for median, you need to arrange your data either in increasing or decreasing pattern. So let's still have the same example that we have on our first data set. You have 18, 12, 15, 17, and 16. So that would be our scores from the quizzes of a student. So let's arrange them. So for the sake of this one, it is up to you if you would want to arrange them from increasing values or decreasing values. But with our lecture for today, we'll have it on an increasing pattern. So the lowest value that we have is 12, followed by 15. Next would be 16, 17, and the highest would be 18. So for this given data set that we have a total of 5 data, which is an odd-numbered data set. So for our odd-numbered data set, it is actually easy to identify what would be the median. You just simply divide our data set into half and look for the middle value. So for here, you have two measurements or scores on the left side, and you have another two on the right side, and the middle value that doesn't have a pair here would be 16. So for this given data set, our median would be 16. But it will now differ if you have an even numbered data set. So for an even number data set, let's say you have 12, 15, 16, 17, 18, and then 19. So if we will be dividing our data set into half, you have both three measurements on the left and the right side. So how will you be able to identify the median score or the middle score for this given data set? You simply obtain the average of these two values that would be nearest in the middle part of our data set. So it would be 16 plus 17 to get the average divided by 2. So 16 plus 17 divided by 2 is equivalent to 16.5. So for this even number data set that we have as our second example, our median is equivalent to 16.5. So for the next measure of central tendency that we will be discussing, which is the last M, we have our mode, which is the most frequent score that will be observed in our data set. Our mode would actually be considered to be reported as either of these four. Depending on our data set, it may be a no mode, it could be unimodal, it could be classified as bimodal, or it could be considered also as multimodal. So let's describe each types of modes that we have here. When we say no mode, simply from your data set, there is no repeating value. We'll have examples later on. For unimodal, you have one value that could be observed more as compared to the other data from your data set. Next, bimodal, you have two values that are observed more as compared to the other data from your set. And multimodal, you have three or more values that could be observed more frequently as compared to the other values from your data set. So let's have an example. You have a data of 1, 3, 5, and 7. So a total of 4 data in this data set that we have. Are there any repeating values or are there any scores that we could observe more as compared to the other measurements that we have? The answer is not. So for this type of data set, it is actually considered to be no mode. But do take note that a no mode is different from a data set that has a zero mode. So how could we identify what is a data set that has a zero mode? So let's say you have a data set that has measurement 0, 1, 0, 3, 0, and 2. So from this data set, the number 0 or the measurement 0 is more frequently observed as to the other data that we have from our set. Next, for a unimodal, let's say your scores are 14, 16, 13, 16, and 19. So from this data set, 16 appeared twice. So you have one mode, or this is a unimodal data set. Next, for a bimodal, let's say you have 14, 16, 17, 13, 16, 19, and 17. So both 16 and 17 are observed twice in this data set. So this is a bimodal data set. And lastly, for multimodal, you have three or more. So 14, 13, 16, 17, 13, 16, 19, and 17. So 13, 16, and 17 both appeared twice, and they are being observed more as compared to other scores that we have, specifically 14 and 19. Hence, this is an example of a multimodal data set. So do take note that our mode would actually represent the peak of a curve. So we have now discussed the different measures of central tendency. So mainly we are focusing on the number of our data sets as well as the frequency of how we have observed this specific data from our set. So we have different ways of plotting or representing our data, just like what we have discussed on our previous lecture. We could utilize a simple Gaussian curve. So this is also called as our bell-shaped curve. So for our Gaussian curve or our bell-shaped curve, do take note that the middle value in our x-axis would represent our mean. If we bisect or divide our curve into two parts, do take note that your curve would have its highest point, or what we consider as its peak, which would represent our mode. And somewhere in between this data that would bisect our data set would be our median. So for each of our data, the distance of one another is being described by the standard deviation. So you have here your positive 1 SD, positive 2 SD, and positive 3 SD. We have here on the left side the negative SD line area, negative 1 SD, negative 2 SD, and negative 3 SD. So we'll discuss this further as we go along with our discussion. We'll have also an example on how we could plot our data. Aside from our Gaussian curve, the one that is being widely utilized for intra-laboratory quality control management is what we call as the Levy-Jennings chart. So for your Levy-Jennings chart, we would have an X and Y axis. Still, the middle value for your Levy-Jennings chart would be your mean. The values or data that is below your mean would be the negative SD line area. So you have here your negative 1 SD, negative 2 SD, and negative 3 SD. And the ones that would be above the mean value would be your positive SD line area. So you have plus 1 SD, plus 2 SD, and your plus 3 SD. So this again would be identifying the dispersion of your data, your standard deviation. So since I have already discussed that, we'll proceed with the discussion of the measures of dispersion in a while. So let's have a summary first on when we should utilize the mean, median, and mode. So do take note again that your mean, your median, or your mode, median, and your mean would represent the central position of your dataset. But they will be utilized best depending on the type of variable that you have. So let's say you have your type of variable, and on the next column that we will be representing the best measure of central tendency to be utilized for each type of variable. So if you have a nominal variable, it is best represented using the mode. If you have ordinal variables or data, it is best represented with a median. If you have data that could be classified either as interval or ratio, but you take note, it is not skewed. So we'll discuss this further. It is best to utilize the mean to identify the central value. And if you have interval or ratio that is skewed, it is best to be described using the median. So let us now proceed with the discussion of the measures of dispersion, which is also referred to as the measure of spread. So this is actually being utilized to describe the variability in a sample or in a population. So this is actually utilized in conjunction with the measures of central tendency. We will not be able to compute for the standard deviation without even knowing first what is the mean or computed average of a certain data set. So let us have our standard deviation. Your standard deviation, just like what I have discussed earlier, would be the measure of spread of our scores in a data set. The standard deviation would measure how concentrated the data would be around the mean. So let's draw again our Gaussian curve. So you have a bell-shaped curve that if you bisect the middle value for our graph would be our mean. The highest point or the peak would be, again, our mode, and somewhere in between would be our median. So do take note that for each side of our areas, the left and the right side of our curve, it will be represented by a positive and negative SD line areas. So we have 3 areas for both sides. Again, you have your plus 1 SD, plus 2 SD, and plus 3 SD on the right side. And on the left side, we have our negative 1 SD, negative 2 SD, and negative 3 SD. So let's represent each area one by one. So we have our positive 1 SD line area here, which would be marked red. And your positive 2 SD line area here, which would be marked yellow. And the last one, your 3SD line area from your positive to the negative 3SD line would be marked green. So all of these areas would represent a certain percentage on the probability of how much of our data would fall within those lines or area. So within our positive 1 and negative 1 SD line area, around 68% of our data would fall in this area. Between the negative 2 and the positive 2, around 95% of our data could probably fall within these lines. And between the negative 3 and positive 3 SD line area, around 97% of our data would fall within this area. So do take note that both of our sides, the positive and negative 2 SD line areas, would have a tail if we are referring to our Gaussian curve. This tail would actually refer for our basis if we are going to accept or reject the null hypothesis. So we'll discuss that on our first lesson for midterms. So do take note again that whether we are utilizing the Gaussian curve or our bell-shaped curve here, our middle value would be the mean for our x-axis. And for our Levy-Jennings chart, so let's have a simplified illustration, the middle value would still be the mean. So the spread of our data would actually revolve with the mean of our data set. So what type of data should you use when you calculate the standard deviation? So again, this is being utilized in conjunction with our measures of central tendency, specifically our mean values. This is mainly to summarize continuous type of data. And do take note, it is appropriate only to utilize our standard deviation if our continuous data is not significantly skewed or it does not have any outliers. So we'll discuss that later on. What is the image for us to identify if our curve is skewed or not? It would depend on the distribution of our data. So for our standard deviation, we could refer to it as either the SD or we could also utilize the sigma symbol. So for the computation of our standard deviation, it is the square root of the sum of your x minus mean squared divided by n minus 1. So there would be times that in some reference books, you might observe that there would be a computation for our standard deviation as the square root of the summation of x minus mean squared over n only. So your n minus 1 actually refers to the degrees of freedom. This formula on the rightmost side of your screens is being utilized for the computation of the population standard deviation. And the one that is on the right side, the one that I have initially listed, would be for the computation of a sample standard deviation. Mainly for the researches that we conduct, we mainly do sampling. That is why for the computation of the standard deviation, we utilize the formula summation of x minus mean squared over n minus 1, and you get the square root of the answer. Aside from standard deviation, we have the variance. We'll have an example later with the computation and with the utilization of these formulas that I am presenting to you right now. For the variance, it is another way of calculating the deviation of a group from the scores coming from your mean. So just like with our standard deviation. And interestingly, for the computation of our variance, which could be represented as S squared or sigma squared, it is actually the summation of your x minus mean squared over n minus 1. So you just simply omit the square root function from the computation of your standard deviation. So it is simply the squared value of your standard deviation. So that is how we compute for the variance. Next measurement of spread that we will be discussing is the range. So the range would define the difference between the highest and the lowest value from your dataset. It would be the maximum minus the minimum. So let's say, for example, you have a range of data or a data set rather, whose scores would be as follows: 4, 8, 1, 6, 6, 2, 9, 3, 6, and 9. So you need to identify first from your data set which would be the ones that would be the minimum value or your lowest value. So from this data set, it would be 1. And your highest or maximum value from this data set, which is 9. So you simply subtract both of this. 9 minus 1, and your range would be equivalent to 8. But do take note that there is actually a bias with the computation of our range. Even though that your range could be utilized for ordinal type of data, there could be a possible bias with the computation of the spread of our data if we are only to use the range. So as it may be insensitive to say this, but usually range is being utilized as a measure for dispersion if you are going to present or discuss this specific topic with people that doesn't have much of an awareness or doesn't have much of a knowledge with regards to statistics. So let's say you have an example of a data set 1, 1, 1, 1, and 9, and another data set of 1, 3, 5, 7, and 9. So technically speaking, you have a data set here that would have different values or scores. But if we are going to compute for the range, the highest value for both data sets that we have here is 9, and the lowest value would be the same, which is equivalent to 1. And still, even though we have a different data set here, the range that we could compute is the same, which is equivalent to 8. Next one, for the measures of dispersion, we also have the coefficient of variation. This would measure the relative variation from our data, and it is always expressed in percentage form. This is being utilized if we are going to compare two or more groups. So how do we compute for the coefficient of variation? So it is represented as CV, which is computed as your standard deviation divided by your mean multiplied by 100. So again, we need to multiply it 100 since we express our coefficient of variation in percentage. So let's have an example for the application of the computation of the different measures of spread or dispersion. So let's utilize our example for the computation of mean earlier. You have quiz number and your scores. We'll have a total of 5 quizzes. So quiz number 1 is 18, quiz number 2 is 12, quiz 3, 15, and quiz 4, 17 and 16 respectively for quiz number 5. So what you need to identify first is the mean of your values. So your mean is the summation of x over n. So let's recall. 18 plus 12 plus 15 plus 17 plus 16 divided by 5 is equivalent to 15.6. After identifying the mean, the next thing that you should do is to create a table. So the x would refer to your values or your scores. So let's write them down. 18, 12, 15, 17, and 16. And your x bar is your mean. So 15.6. The next column that you must prepare is this difference between your data and your mean, followed by the squared value, x minus mean squared. So let's compute. First one that we have is 18 minus 15.6. That would be equivalent to 2.4. Then we square the value. Alright, let's clear that. 2.4 squared. That would be equivalent to 5.76. Next. Excuse me for a while. Next one that we have is 12 minus 15.6. That would be negative 3.6. You square the value. That would be equivalent to 12.96. So it would be easier for you to identify the summation of x minus mean squared if you continuously compute for the difference of your data and your mean, and you square immediately the value. Since for the computation of the standard deviation and the variance, we only need the sum of the x minus mean squared. Next. 15 minus 15.6. That would be equivalent to negative 0.6. Square that, and you have 0.36. Next one, 17 minus 15.6. 1.4 squared. That is equivalent to 1.96. And the last value that we have is 16 minus 15.6. That is equivalent to 0.4. Then you square the value. That would be 0.16. After getting the mean and creating your table, get now the total of your x minus mean squared column. So summation of x minus mean squared. So that would be 5.76 plus 12.96 plus 0.36. plus 1.96 plus 0.60. So that would be equivalent to a total of 21.2. So since you already have your mean values, you have already identified the summation of x minus mean, you may now proceed with the computation of the different measures of spread. So starting from the easiest one, let's have the range first. Our lowest value is 12 and the highest is 18. So 18 minus 12, and that would be equivalent to 6. Next is for your standard deviation. It would be the square root of your summation of x minus mean squared over n minus 1. So that would be the square root of 21.2 divided by, you have a total of 5 data minus 1. So that would be 4 since we are computing for the sample standard deviation. So let's compute. Square root of 21.2 divided by 4. And the answer is 2.30. So 2 decimal places for our computation. Then, for the computation of your variance. So you just simply square your standard deviation. So 2.30 squared is equivalent to 5.29. And lastly, for our coefficient of variation, it would be your standard deviation divided by the mean times 100, and that would be equivalent to 2.30 divided by 21.2 multiplied by 100. So let's compute for this one. 2.30 divided by 21, divided by the mean rather. Let's repeat. Your standard deviation is 2.30 divided by the mean, which is 15.6, multiplied by 100. 2.30 divided by 15.6 times 100. And your CV is equivalent to 14.74%.